Okay, this is Tech Math 3 Pre-Calculus Combined, and we're in section 8-2 on this very second day of class. And we have some rules. So we'll do rules and regulations first. So if I have a to the 1 over n, who'd want to do that? A raised to an exponent that's a fraction, and that's the same as taking the nth root of that guy. So in my calculator, I can use a fractional exponent to do a radical of something or another. We can do that. And if I have I got an m on top and an n on the bottom, then that's the same as taking the nth root of a to the m, or it's the same as taking the nth root of a raised to the m. Well, maybe I might be able to do that. It'd be hard to say. The issue is I have to speak up. So let's see.
M over n equals, is that m? Radical.
The real issue is what happened to my recorder here. Because it should be down here. I should be seeing it. Did I mess something up? La la la. Not down there. Oh, there it is. It's hiding. No, we're doing okay. Show recording bar. There we go. Yeah, it's still there. La la. Okay, I will now attempt to talk louder. No. So the front row, turn down your hearing aids. Yeah, was that a good idea? Let's see. I guess those are the only rules we have. That's not. Yeah. So you'd rather have me do it different? All right. So a raised to the b over c. So that would be the same as taking the cth root of a raised to the b, or it could be the cth root of a raised to the b. Is that what you're complaining about?
Yep.
Yeah. Typical. But math people uses m's and n's to confuse the student on purpose. How can we possibly proceed if you're not confused? That befuddles the whole purpose. Yeah. Yeah, you got that. Yeah, maybe. I don't know. All right, number 2. What does number 2 say? Evaluate 49 to the 1/2. Well, I can just put that in my calculator. Why would I want to do anything? But the square root of 49 is the same as the square root of 7 squared. And if I take 7 to the squared and I raise it to the 1/2, that's the same as 7 times 2 times a half, which is 7 to the first. Did I exhaust all possible ways of solving that problem?
Nobody exhausted my brain.
Yeah. So there's lots of ways to do that. So if I recognize this 49 as 7 squared, then it's easy to figure that out. But if not, I can just put in my calculator and put 49 raised to the 1/2 power, and it's going to give me a 7. I hope. Well, it's not going to give me one. I don't have enough light to even turn my calculator on. All right, number 6. 8 to the 3, 2 over 2. 2 over 3?
Can you go back up a little bit for a second, please?
Yeah, I sure can. Yeah, how's that? Is that all right?
You're boring.
Yeah, is that better?
Thank you.
Am I going too fast already?
Yes.
Oh, bummer.
Get used to it.
See, where was I?
So we wasn't expecting anything
To the 2/3, and we just write down 4. Now again, I can just put this in my calculator. It's going to tell me it's 4, right? I don't really have to do much. But I am. So if I have 2 cubed, that's the same as 8, right?
Right.
And 2 over 3 times 2 cubed, that'd be 2 to the 3 times 2 over 3, which is the same as 2 squared, which is 4. And that's what I wrote down 4 for, because I saw that. I saw it through that. Yeah, that's right. I would. I just write down 4.
I did it
Yeah.
on my calculator.
But again, there's no reason you just can't put it in your calculator.
That's what
Yeah,
I'm
there we go.
saying.
So 8
That's what I'm saying.
raised to the 2 thirds.
So we just do.
21 and a third, because I forgot to put parentheses in. Yeah. All right, now, if you don't recognize 8 as 2 cubed, 4. Oh, the calculator says 4? Okay, so I can go on now?
No.
I did.
Your calculator doesn't say 4. Get a new calculator. Number
I got
12,
a 50 calculator.
8 to the minus 1/3. All right, that's 2. No, it's not. It's 1/2. 1/2. Okay, so if I had 8 to the minus 1/3, that's the same as 1 over 8 to the 1/3, which is the same as 8 2 cubed. No, 1/3. 1/3, which is 1 over 2 to the 3 times 1/3, which is 1 over 2 to the first, which is 1/2, which is what I had to begin with. Okay? That's probably okay. All right, so we'll move on to 34. 34.
That's a hell of a jump.
28. We'll move on to 28. Number 28. 8 to the 2 thirds divided by 8 to the 1/3 equals 2. Okay, did I show enough work? So I have 2 cubed raised to the 2 over 3 divided by 2 cubed raised to the 1/3. So I'm going to get 4 over 2 equals 2. Okay, good enough?
Wait, I don't know.
Or I could say 8 to the 2 thirds divided by 8 to the 1/3 is the same as 8 to the 2 thirds minus 1/3, which is 8 to the 1/3, which is still 2. I could do that. Or I could just put it in my calculator and it would tell me it's 2, and I could write down a 2 and move on to, yeah, let's hope a problem as simple as that's going to be on some test. Well, then it looks like that. Yes, a problem. I know it's difficult to believe that there are math problems that we can actually do in our head and write the answer down to. I know that's hard to believe, but there are certain problems like that. So in Alex's case, he normally, because they're odd problems, he would have the back of the book open where the answers are, and he'd put 3, 1/4, 6, 1/8, and just copy it out of the back of the book, thinking that I would just assume he's smart enough not to show any work, right? Well, that might work in chapter 8, but it probably won't work in some other chapter. You know? Probably not. Never can tell. All right, so what are we doing? How far are we going?
Don't worry, I was there.
57. All right, so I guess we should do 56 next and move on to the next thing because these are way too easy. 56, yeah. So we have 2x to the 1/2 plus 3y to the 1/2 times. I mean, just trying to write the problem down so it's correct is going to be a problem, right? 1/2 minus 4y to the 1/2.
0.
Okay, now, we know from the front of the book, the front cover of the book, you have a front cover there, right?
Yeah, front cover.
Yeah, front cover of the book, that if I have if I have a plus b times a minus b, that's the same as a squared minus b squared, right? We know that's in the front of the book. Where is it?
Not the soft cover.
Yeah, number 2 under algebraic products. Okay, and on the front cover. So we know that. I see that I'm in the form. I'm not. I'm not in the right form. Oh, bummer. After all that lead up to this is going to be an easy problem.
Good thing it's screen capturing.
Yeah, it's a good thing that came in. Otherwise, I would have hosed it all over. Okay, well, first one times first one. 6x to the 1 quarter. 1 quarter? X to the 1/2 times x to the 1/2. That'd be x to the x, right? Yeah, just x. Okay, 6 to the x. This guy times that guy. Minus 8 x to the 1/2 y to the 1/2 plus 9 x to the 1/2 y to the 1/2 minus 12 y. Alright, so the guy in the middle, I see that it's the same, so I'm going to write down a final answer. Final answer 6x. Oh, is that called FOIL? I don't know. That's what a net would call it, but I wouldn't call it that. I just call it working the damn problem is what I call it. Okay, so I'd end up with something that looks like that. And is that what I'm supposed to do? Perform the operation. Simplify if possible. Okay, well, can I get any more simpler than that?
Plus x to the 1/2 y to the 1/2.
Right here?
You have minus.
Oh, I'm saying, yeah. You mean like 9 minus 8 is a plus 1? Is that what you're trying to point out? I was just trying to figure out if the guys in the front row was going to point that out to me. But, see, it's a job of the front row to correct those problems, but obviously it's going to have to fall to the second row back. And that's perfectly okay. These guys are perfectly happy with you finding it out before they do.
Right.
Yeah. But yes, I did put a minus sign there on purpose. Yeah, sure I Yeah, sure I did. Okay.
Oh, I didn't.
Yeah, I remember that.
You're like way behind.
Okay, so where are we going? We're going to chapter 9 next. Are we going fast enough yet, guys?
No.
No? Okay.
We're cruising.
Yeah, not going fast enough? All right, chapter 9, section 1. All right. Oh, this is much more fun. Much more fun. So, oh yeah, I know it's not. Yeah. 9-1. So if I have something that looks like y is equal to b to the x, and I want to make a graph of that, I just put it in my graphing calculator, have it do it, and then put it on a piece of paper. I mean, it shouldn't be that hard, right? But what I would do is I would make a graph x, y. So I've got y is equal to, let's see, 4x. So if x is 0, y is 1. If x is 1, y is 4. If x is minus 1, y is 1 quarter. If x is 2, then I'm at 16. Minus 2, I'm at 1/16. And then I'd go and graph that. Yeah. So 0, I'm at 1. So there I am at 1. 1, I'm over here at 4. And 2, I'm up here at 16. And then at, oh, that's a 1. And then at minus 1, I'm at 1 quarter. And then at minus 2, I'm going to be way down here in the graph. So then I draw it. Da, 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 da. Perfect. And it's asymptotic to the x-axis, which means it's never going to cross the x-axis, which means my graph is hosed. So I can't. There, now it's perfect. Now it's not crossing the x-axis anymore. Yeah, that's pretty good. And if I was doing something and had something slightly different, yeah, we'll just say we have y is equal to 1/2 x. 1/2 x? Yeah, 1/2 x. Okay, so now we'd make another thing, x and y. So if x is 0, I get 1 again. 1, I get a half. 2 I get a quarter, minus 1 I get 2, and minus 2 I get 4. And now I have something that still passes through there, but does something like that. There, that's bad. Well, that's pretty bad. Let's see. If I correct it, though, I'm just going to mess up everything. Well, now we have to put an equal sign back in. So at minus, what happened here? Oh, at minus 1, I'm at 2. Minus 1, I'm at 2. Okay, so that's good. And at minus 2, I'm at 4. All right, so that's better. Anyway. So I asked you to graph something. Get out your crayons and be as accurate as you can with your biggest crayon, right? We're not trying to make these things perfect. Yeah, not trying to make them perfect. So bring a set of colored pencils with you, but don't sharpen them.
Yeah.
Yeah, because then there'll be too much accuracy there. Yeah, as vague as possible, right? Okay, well, that's all there is to this section. Draw some graphs, and that's why we don't do very many. Oh, I guess we do. Yeah, no, we don't do very many. We just do 5, right? Okay, so we'll do number 2. Number 2.
Number 1.
All right, so we'll do number 2. So we'll open up Maple. We will? Yeah, sure, why not? Open up Maple. Well, you want a pretty graph. That's the only way you're going to get it, right? Open up Maple and go to Tools, Assistance, and Plot Builder. Going to add an expression. Let's see, y. Ask y. Where's the y in this keyboard anyway? Y equals 3 raised to the x. All right, accept that. Boom. Excellent. Okay. Plus or minus 5. I think we ought to go the y. Let's see. If the y is plus or minus 5, 3 to the x. The x should be something small. The y is going to have to be something big, though. We don't have to go. Y isn't going to go below 0, so we can go to 0. But we're probably going to want to go. What's 3 to the 5th? Anybody know? 3 to the 5th. 270. So we'll go up to 300. Okay. Boom. Plot it. There we go. Perfect. What more do you want?
All right, so everyone get Maple.
Yeah, everybody get Maple and have a laptop and everything will be fine.
Burn a copy off yours.
Yeah, I could do that. Or we could say y is equal to 3 to the x. Y, x. X is 0, y is 1. X is 1, this is 3, 2, 9, minus 1, 1/3, minus 2, 1/9. And boom, change color of the crayon. So we're there. We're going to go and do this. Notice they all look the same. So that's obviously that's 1. And then when I'm at 1, I want to be at 3. All right, perfect. Don't need any more detail than that. What? Who? What?
Do you want us to plot like a third specific?
Well, it looks to me like I have 5 there. That should be more than enough. You know, I certainly wouldn't go past 5. Yeah, yeah. I wouldn't. Of course, I'm one of those types of guys that would never do anything like that. Go back to the Maple graph. Oh, yeah. So the only way you could mess up this graph is not go through 1. I mean, that's almost, really. I mean, so if you don't go through 1, then I know you missed it. As long as you're going through 1, then how can I possibly complain? How can I possibly complain about what the rest of your graph looks like? Number 2, so 22 is next. Y is equal to 2 to the minus 2x. All right, well, maybe we'll put the delete out over here. Let's see. So I have x. All right. I'm going to make 3 lines. I've got an x, I got a minus 2x, and I have a y. Okay, so when x is 0, this is 0, that's 1. When x is 1, this is minus 2. Minus 2 raised to the, well, that'd be 1/4. 1/4. When I'm at 2, I'm at minus 4. And when I'm minus 4, that'd be 1/16. And then if I'm minus 1, that would make this guy 2, which would make this 4. And if I'm at minus 2, that would make this guy 4, which means I'd be at 16. All right, now that's way too much work. All right, so boom, boom, minus 2, minus 1, 1, 2. There's 1. There's 4. There's 16. All right, so I'm all set. I'm up here. I start coming down this way until I get to there. I pass through here. I make it to there, and then I make it down to there. Other than the graph being completely and totally hosed, everything else is right. Alright, so try to make it more cool through there. Is that cooler?
That's cooler.
Except now this guy is not there where I want him to be. Okay, we'll erase the whole thing and see if we can. Way to go. We'll erase the whole thing down to there. All right. Now we want to be there. And then we want to be here. All right. Okay, is that better?
That looks a lot better.
Yeah, that's just totally, completely okay. All right. All right. Now we're gonna do 36, and then move on to the next section. Number 36. We want the third root of 12, and we want to find it rounded off to 3 significant digits. Okay, so I take my calculator and I get enough light on it so I can actually see the stupid thing. Oh, there we go. I got my calculator. I'm going to go 12 raised to. No, that doesn't work. Clear. 12 raised to the 1/3. And this time I'm using parentheses, so I actually do that. And my calculator says 2.289428483. And the problem says I want 3 significant digits. 2.29. Final answer. Okay, good enough. But the only way you're going to do that problem is in your calculator. You're not going to mess around doing anything else. Yeah. Okay, good enough? Well, let's do 40 just for the heck of it. Maybe we can do 40 without our calculator. Third root, number 4. Maybe I can do 40 without my calculator before you guys can do it with your calculator. What do you think about that?
36.
Yep.
36? All right, God, I knew I could do it. All right, so if I take 4, 6, 6, 5, 6, I recognize that it's divisible by 3, is it not? because if I add up all the digits together, they're divisible by 3, therefore the whole thing's divisible by 3. So this is 3 times 1, 5, 5, 5, 2. Okay, now 1, 5, 5, 5, 2, I add those digits together, I see that they're divisible by 3. So this is 3 times 5, 1, 8, 4. Okay, now I look at those digits, I see that they're divisible by 3. So that's 3 times 1, 7, 2, 8. I see that that number is divisible by 3. So that's 3 times 5, 7, 5, 7, 6. I add those together, they're divisible by 3. 3 times 1, 9, 2. That's divisible by 3. 3 times 6, 4. 6, 4 is not divisible by 3 anymore, but 64 is 2 to the 6th power, is it not? Okay, so I got 1, 2, 3, 4, 5, 6. So this is 3 to the 6th, 2 to the 6th, and I want the third root of that. Okay, so that would be 3 squared times 2 squared, which is 36, which is what everybody's calculator said it was. Okay, so if I'm on a desert island and I have that problem and I don't have my calculator, I can still do it. Yeah, the boat will not be coming until I get the problem done.
That or you're in a dark room.
I could be in a dark room. It's hard to say. All right. But what I would do is I would put it in my calculator first, and then I'd worry. If I put it in my calculator and I got 36, then what would happen next? I'd probably go and say, oh no, I need 3 significant digits and I only have 2. Oh, the answer can't possibly be right. And you'd probably put a 0.0 there so that, oh, I got 3 significant digits. Well, no, you're not going to do that. You're going to write down 36.
When you do that, you make it. I'm gonna make it.
That's right. But you could. But if this was a physics class, you'd have to have a 0.0 there, so you show all 3 significant digits, right? Yeah. Anyway, but this is a math class, so we'll go with 36. All right. Well, things are getting more fun, I can tell. Yeah. Section 9.2. And in 9.2, what we have, if we have y is equal to b to the x. Okay, so if we have something like that, then this is the same as saying the log of y base b is x. So these two equations are the same equation. They don't look the same, but they're saying the exact same thing. Huh? So if I have y is equal to b to the x, that's the same as saying the log of y base b is x. Those two equations are the same. So if I what?
That's 9.3.
Oh, 2. 9.2, page 308. I'm looking exactly at what's in the book. I'm not making this up. I know you think I make this up all the time. I mean, I understand that. You know, and in this particular case, I'm not making it up. I'm looking out of the corner of my eye and my trifocals and writing down exactly what my trifocals see, which may or may not be right, but that's beside the point. Okay, so if I have an equation that looks like the thing on the right and I can't figure out what to do with it to solve it, I can turn it into the thing on the left, if that makes it easier to solve. And vice versa. If I have something that looks like what's over here, I can turn it into something that looks over there. Okay. Yeah, either way. So the other thing we're going to do is if I have something that's like I got log of y is equal to x, I'll be able to do a graph of that. So I'm going to graph that. I'm going to do the same thing. I'm going to find y's. I'm going to find x. I'm going to go and do whatever, right? In this particular case, I can't take the log of a negative number, and I'm going to always pass through 1. The log of 1 is always going to be 0. Okay, so my graph is always going to look like something like that, and I can't take the log of a negative number. Now, in Chapter 9 of the textbook, what I'm telling you is true. In Chapter 14 of the textbook, we change our tune just a little bit because it turns out that we can't take a log of a negative real number, but we can take a log of an imaginary number that happens to be negative. Okay, so if when I get to Chapter 14 in the imaginary number thing, we find that I've got an xy plane of numbers. It's only these numbers on the real number line that I can't take the log of. But I can take the log of this guy right there, which is 1 plus I. Or I could take this guy down here, 1 minus I. I can take the log of imaginary numbers that are in the second and third quadrant. I just can't take the log of something that's a real number that's negative. Now in Chapter 9 of the book, there's no distinction because we don't have imaginary numbers yet. So you can't take the log of any negative number, and that I'm saying the same thing, only in a different way.
Yeah.
Yeah. Because there's no such thing as an imaginary number yet, therefore all of them are real numbers that are negative that I'm not taking the log of. Yeah. Okay, I'm glad we covered that. That was just totally clear, right? Clear as mud. Yeah, we needed to know that early, you know. Yeah. Yeah. So when you get to your complex variable class after calculus 3, you'll remember that I told you that, and then things will be much better. Yeah, that'll be about 50 years old when that happens. Yeah. Okay, so I'm going to look at problem number 2. And I've got 7 squared is equal to 49. And what I'm supposed to do is take this exponential form and write it as a log. Okay, so I'm going to say log of 49 base 7 is 2. So all I did is I got y is equal to bx log y base b, that's a different case b, is equal to x. So all I'm doing is just taking this and writing it that way. Perfectly okay.
But the log is always going to be the big number?
No. It's always going to be in this form. It's always going to be in that form. Okay. So we're gonna just for Rumundo, we're gonna do problem number 11 next. Okay, so for number 11, we have 10 to the minus 5. 10 to the minus 5 is equal to 0.00001. Okay? And now we're going to put that in logarithmic form, and we're going to say the log of 0.00001, which happens to be the smallest number, by the way, base 10 is equal to minus 5, unless you think that minus 5 is smaller than 0.00001, which you could think that. I mean, there's some perverted way of thinking that way. You know.
That's 0.0001 still positive.
That's right.
That looks like a, yeah.
Yeah, so Raimundo could have been right,
Could have.
depending on how he was thinking.
I'll get to you.
Yeah, haven't gotten to me yet. Okay, now we got to go. Now we're going to go the other way. Okay, so number 14.
Yeah, you
How can this get any worse than this? Log base 8 of 64 is 2. All right, so 8 squared equals 64. Oh, that was pretty bad. We'll do 22. Number 22. log base 2 of 1/8 is minus 3. So we'll write 2 to the minus 3 is 1/8. Yeah. So that's pretty pathetic, isn't it? So let's hope those questions are on the final.
Yeah.
Yeah. Let's hope. All right. So now we're going to go. We'll do a graph. Number 28.
What?
What do you mean what? Y is equal to log base 5.
You get an automatic, I got to stand right up with a clutch.
What? Who? Where? Am I going too slow again for the front row? Okay, let's see if I can think of a good joke. No, afraid not. They're all bad.
What do you call that? Makes
Right, he's not. We're in the 8 o'clock lab this morning. We're in the 8 o'clock lab this morning, and I'm talking about how on my submarine in a room this big we'd have 150 people, and somebody starts laughing, and what are you laughing about? Well, he's on the Texas out of Hawaii, submarine on the Texas out of Hawaii. Well, I have a son-in-law in Hawaii. Well, what's his last name? Nagowski. Well, he was my chief. So they're on the same boat together. So one of my freshman students was with my son-in-law in Hawaii on a submarine a year ago.
Oh, cool.
Isn't that cool?
That's
Yeah. Talk about a small world. That's almost as bad.
coming out of the submarine.
Yeah, that's almost as bad as going to combat in Afghanistan with Rumundo or something. Yeah. And surviving. Yeah, about the same. Yeah. But so I emailed him to find out the gouge. Why is this guy not on your submarine still? Anyway, I got to graph this thing. Bummer. How am I going to do
a
it?
response back?
Not yet. Hawaii, they're not even up yet in Hawaii. Forget that. They don't get up until noon, which is 7 o'clock our time. Okay. Well, anyway, we know that at 1, this guy's going to go through 0. So we got a point already right there. And we know on this side it's going to do this, and we know on that side it's going to do that, right?
That looks cool.
That was pretty bad, I know. Someday I'll get this graphing done right. Yeah, does that look better? So now we should come up with at least another 2 points, right? So X and Y. So I look at that and say, what am I going to do with this? All right, so I'm going to go 5 raised to the Y is equal to X. I'm going to rewrite it. Right? And then I'm saying, oh, when X is 1, Y is 5.
What?
When Y is 1, X is 5.
Oh, you put it back.
When Y is minus 1, X is 1/5.
I'm glad that you know it.
Okay, so here we are. There's 5. There's 1. Here's 1/5. There's minus 1. There, all done.
Is that 1/5 or 1/2?
Huh? What? But see, if I was looking at this guy trying to get points off of him, I'd be scratching my head a whole long time trying to figure that out. But if I rewrite it like that, then I get points over here, and then I'll be okay. All right, now we get to solve for X. And then we'll proceed from there. Okay, so the log base 6 of 36 is X. X is equal to solution set 2. 2, right? Because I rewrite this and say 6 to the X is equal to 36. X is equal to 2. I can see it here easily. Can I see it there easily? All right. Now, the other thing we could do is we could say log base 6, 36 is x. We could do that. And then we could raise these to the 6, make these exponents of 6. Okay, so on this side I have 6 to the x. What is 6 raised to the log base 6 of 36? 36. It's a trick question. Yeah, it's a trick question. So I still get x is equal to 2, either case. Yeah. So I could have gone and raised them as powers, but I didn't. Yeah. But I already had 2, and I should have quit there, right? Yeah. We're going to do 36 next, number 36. Log base 3 of 27 is x. Now we already know the answer, right? The answer is 3. Yeah, the answer is. What about 9?
9 times 3 is 27 too.
So. Okay, so we don't see it. The front row doesn't see it yet. So we're going to rewrite the exponential as x cubed is equal to 27. Okay, as soon as we do that, we recognize that 37 is 3 cubed. X is equal to 3, which is the same that we got before we rewrote it.
Yes.
Yeah.
You were right. We've done 3.
Now let's see if my calculator will. No, my calculator doesn't do logs in any base other than E and 10. So
You want to use mine?
no, definitely not. I just get a headache. Yeah, it probably has cooties on it. Yeah, you're probably right there. Number 38. Log
I promise you won't turn.
base 27 of 3 is x. Oh,
9.
I'm thinking of probably, no, it's not going to be 9. I'm thinking maybe 1/3. Yeah, 1/3. X is equal to 1/3. That'd be my guess if I wasn't doing anything else. Okay, so I'm gonna change it and say x cubed. No, not x cubed. The base 27 raised to the x is equal to 3. Okay, so this is 3 cubed raised to the x equal 3 to the 1. So 3x has to equal 1. X has to equal 1/3. And somewhere around there you would skip writing things down because you'd come to the conclusion that it is 1/3 way before then. All right, we'll try 42. These are so much fun. 42. Log base x of 3 is 1/2. All right, so x raised to a half is 3, clearly implying x is 9. May not be so clear in the log form, but very clear when I write it as an exponential. Yeah. 46, and then we'll go home. What do you think? Now, oh, we could get ahead, though. 46. We'll vote on it. After I get done with 46, we'll vote on whether or not we should go home or do the next section because we're doing so well. You know, sometimes the instructor might not be able to work the problem. X 64th 3/2. Well, yeah. So I've got that x to the 3/2 is 64. All right, so x to the 3/2. I recognize 64 as 2 to the 6th power. Is that how I recognize that? 2 to the 6th power? Okay. So what we'll do is we will take both sides of these guys to the 2/3 power. And if we take the 2/3 root of x to the 3/2, we get x. All right, so 3 goes into 6 twice. 2 times 2 is 4. 2 to the 4th power is 16. And luckily I'm doing the even one, so you can't look in the back of the book and tell me I'm wrong. Yeah, so that's on purpose. Yeah. So how would you think we should check a problem like that, I wonder? 16. Well, we'll check it by saying if I have 16 to the 3/2, is that in fact equal to 64?
It is.
And so I've got 2 to the 4th raised to the 3/2, which is 2 to the 6th, which is 64. So it is. So we're all set. That's fine. Okay, any other questions? Okay, we're going to do a quick vote. How many want to stay and do the next section today for 10 points of extra credit on the final exam?
Oh, good. Now you're talking.
3 of you, okay. I'm just trying to figure out what type of bribe I need, you know. Okay, so that's good. We'll stop for the day and proceed on schedule on Friday. Friday starts with a quiz.
Great.
The quiz is already there. I'll probably print it out and bring it with me if I
I was hoping
remember.
Friday would be a quiz.
Is it, you mean something on the website?
You haven't looked at their website to see that the quiz is already there?
I can't access it.
You can't access the website?
No, my browser freezes every time I click map.
Oh,
That's
okay.
on my browser.
Yeah, typical.
In other words, we can just go online, print it off, and have it done before we get here?
You could.
Yeah.
I would assume that
Well, I know what I'm doing Friday during lunch.